Hello, this is GMA Laser Designs. What I'm doing here today is showing you my DIY 3-jaw rotary, Chuck Rotary that I've developed, and I am selling plans and kits. This is an introduction to it roughly to begin with, and then to go over 3 other specific aspects of this that needs to be approached prior to the actual assembly instruction. What I need to go over is the cutting of the plexiglass, the development of the motor, stepper motor wiring, and then also to go over the actual 3D printing of parts. Hope this doesn't get too long. As you can look at here on the screen, this is the um, design for the plexiglass cuts. This is first thing you're going to see here is stop, read this instruction. Right here, you're going to see 2 pieces that need to be cut out onto the plexiglass to test to make sure you got the right item. So what you'll do is grab these. Now what these are locked. They should be locked. Do a right click, copy. Come over to where your plexiglass is going to be at. Paste it. Send back in and cut these 2 pieces out. Once you cut those out, we're going to next thing we're going to talk about on the um, plexiglass is what to use on the actual light burn file that I've got here. What I've done here, you can see the normal bed um, area and the area that I've got the actual plans for the plexiglass cuts that need to be done here. What I've done is I've done 2 sets. There's little minor changes between these 2. This set is if you're using metric M5 bolts. This set is you're using the American Standard bolts. Basically, the bolts that you would be using in the metric is all M5s, and in the American Standard SAE, whatever you want to call it, English unit, is number 10. So that's the only difference between this set and this set. The holes are a little different, is the only real difference. Now, let's zoom in here and look at the drawings. These 2 right here are the only pieces that are 1/8 of an inch. The rest of it is 0.22 inch thickness. I can't stress that enough. We talked about getting our test and finding out. The reason you have to do it, if you look, every circle that's got layer number 26, no, T1, excuse me, I changed that, T1, do a right click. Every place that the circle would have to be changed. And you would have to change them so that when the alignment, you get the space between here and here has to remain the same. The space between here and here has to remain the same. So you got to change the outsides if you're changing anything. Don't do it. It got me so I designed this and it got me so messed up. That's why this whole presentation has been delayed a couple of days. It's getting some of this taken care of. So like I said, get 0.22 inch plexiglass. You guys in Europe, you're on your own, buddy. I think 0.22 comes out to 5.6 millimeter. I don't know what plexiglass is sold over there. You could probably get away doing this whole setup with wood, but the problem with doing it in wood is could warp on you and that type of thing. Plexiglass isn't. This is a pretty solid system that I've got here. But anyway, I digress. If you look at these two pieces here, you see these green line, those are etched. Everything that's green is going to be etched out when you hit it. This is to line these up because when these, if you look closely here, these cogs are perfectly set up for a G2 timing belt. And I got my laser dialed in so it gives a real sharp cut. And the narrower, I would suggest you do a ramp test on this before you cut, just so that you've got a good indication. This is one of the fine cuts because these are pretty well set as far as everything fitting. Like these, look at the, I'm not going to get into the where these whole fit into and so forth, but read or watch the video. The videos that I've got are very, very detailed. That do it step by step. You can build this as you watch my videos. The two videos together are going to be over 2 hours. I did it that way on purpose so that it would be very specific. So you'd be knowing what to put it. And I apologize. I'm not very well spoken. The Parkinson's is affecting my speech too. So anyway, here are the pieces. If you're using metric, these are the pieces that you're using if you're using number 10 bolts. What I did here, this is a scale check. You can, when you drop this file into yours, see if this comes out 1 inch by 8 inch, 40 millimeter by 200. That's what the box is. Just a quick way to check to see that if it came in to scale. Now, what I'm done with everything is I've locked. If you looked here, I've locked it. You can't move. You can grab it and so forth. You can copy, take it over here and paste. You can unlock this if you want, but I wouldn't. Honestly, what I would do and the way I do it is I would pick everything that's going to be lasered, take a copy, come over here and paste. And what I would do is now everything, these are not locked. They're grouped, but they're not locked. Take my pieces up, set them up to be cut. When I'm done with those, because I do my stuff on individual pieces because I get my plexiglass for free. I've stated that before. I've done work for the local hardware guy, and the pieces that he normally would throw out, every piece that I've ever used in plexiglass, I've gotten for free because I did a couple of jobs for the guy for free, and he has reciprocated ever since by giving me the stuff that he would normally throw out. So what we do, cut that, and then I move it off to the side. Get these pieces, move up here, arrange, cut, move off the side. That's how I keep straight of what's been cut, what's been done, so forth. So when I'm done, I want to clean up, just delete everything, and we're done. Once again, leave this locked. If I come over here and hit delete, nothing happens. Comes up an error. Oh, this is new. I just downloaded the update. So that's a new note that comes up when you do something won't work. So hopefully I made this as idiot proof as possible. And I'm referring to myself, not you. Okay. There we go. That should take care of that. Okay, got the two pieces. Like I said, I'm not that great with this video stuff, but I'm trying. Got the two pieces that have been cut out. You'll see on this, it's 0.22 thickness. That's the American standard for cheap way of saying quarter-inch. It's just a cheap way of saving 0.03 inches of plexiglass material, like a 2x4. 2x4 is not 2x4. It's 1.5 by 3.5. Just a cheap way of saving material. So anyway, make a long story short, the reason for this is to do this test. You want to take this piece, put it into the slot. If it goes into the slot and it's not super loose or super tight where you have to bang it in, this is a snug fit. That tells me that this material is the correct thickness for what this project was designed for. If it does not go in, then you got the wrong thickness material, and I strongly recommend that you get the 0.22. If you got 0.25, then you're going to have to go in and correct on the design drawings all the tabs that are not the tabs, but the cutouts for where the tabs go into have to be resized, repositioned, and I want to tell you, it's a pain in the butt. I designed all this. It's a pain in the butt. So try to stick with the 0.22 if you can. As far as our metric friends over in Europe that are looking for this drawing, I got a couple of them that have already mentioned that they want to purchase the plans. I don't know. You're going to find out what you got over there. Get in touch with me. Maybe I can help you. Maybe I can't. But these drawings are set for 0.22. All right. These are the stepper motors that I've purchased to be placed into the kits. They come with just the wiring, a short stretch of wiring. It's not long enough for the project. I am going to be providing wire in the kit. I will provide also the aviation plug that needs to be plugged to be attached uh, for our particular situation. I am not going to do the wiring for these plugs unless you pay me for it. I'm sorry, but that's just the way it is. It's too big of a pain in the butt, and it takes about an hour for me to do a complete wiring hookup. So it will be your option. That's the best I can tell you. If one of the things that you need to also worry about is if if you do not have an aviation plug jack for where your Y stepper motor connects to, then you're going to have to figure that out for yourself. I do not know. The only thing I really know is how to hook up an OMTech, the Chinese red black, or the gray blues, whatever. They all pretty much have the aviation plugs. If you have the aviation plug, this will work. Now, if you look at the stepper motor controller, stepping driver. If you look at the chart that's on the side of your controller, you can't see mine because it's buried, so I had to look this up. But this is the exact number that's on mine. This chart tells you what switches to be turned, and in this particular case, on mine, my first switch is off and the second switch is on, but the third switch is off, so it's not this one. So you come down to find the next off on. So you got an off, on, off. Now what that tells me is that my controller, my driver, is pumping out a peak of 3.5 amps. The motors that we're getting is 2.8. So we need to step it down a little bit. But the one thing that's not showing over here is on this is showing what switch number 4 does. Switch number 4 is the main one that we need to take care of. So remember that we should step down to on, off. Now let me change over. All right, we're back. Now, if you look at this, this is showing the setup on my controller. Now the X we don't worry about. The Y controller is the driver, is one that we need to worry about. This is the normal setup right here for my particular laser. So 1, 2, 1 is off. Once again, coming down to 1 is off. 2 is on. 2 is on. 3 is off. 3 is off. So this is the one that we need to worry about. So this is putting out a peak of 3.5 amps. Now, what's happening here is switch number 4, which once again is not shown here, is the one that's really controlling. What's happening is switch number 4 is telling it to have peak power at all times. You might need that running the main laser, but on the rotary, you don't need it. And that is why these motors are getting hot. It's because this one little switch right here needs to be flipped up and over. And that will cut the temperature problem down 80%. The rest of it is you need to get 1, 2, 3 changed. You probably need to kick it down to, say, a peak of 3 amps, which is close enough to the 2.8 that so that it's not going to be an issue. So we would need switch 1 on. So switch 1 would need to be flipped to the right. Switch 2 on. It's already there. Switch 3 off. Already there. So the only thing you got to do is switch 1 to on and 4 off, and you've got your entire power situation taken care of with the rotary. Now, once you're done using the rotary and you switch your Y back to running on the main laser bed, you need to switch these switches back to where they were at. I hope this explains it well. If you have any questions, get a hold of me. I will try to help you as best as I can. Okay, the final part that we need to talk about is 3D printed parts. I did a lot of testing, and I mean a lot of failures. One thing that I will find out here is that you need to make all your parts at least 50% infill. This piece right here is the weakest link of everything. It's the most important part of everything. This is where the drive shaft comes through and attaches. claws, scroll plate, and so forth. But yet it is weak, even if you did it at full string. Right here. Be careful. Be careful because you have to take, this is one part that I have not messed with yet. I cannot believe I had the part. Pliers here just a minute ago. Here it is. Anyway, like taking this part, you have to really get the support system that has to come out. It gets easy and then it gets harder, and then when you get into the middle in here, you have to take your time and work your way through it to get into it. And then you have to get, once you get into there, you have to get the support way down in here out. You have to get all of this out in here because the jaws that slip through here go into the cavity here when you get them closed down. And what happens is that if you use high speed, kick up the speed and the so that the printing gets done faster, then what happens, you get a lot of burrs in this particular situation, and the support doesn't come out very well, and you have to get in here with the filing and file the edges down, otherwise these will not slip in. I actually did redesign these things completely from scratch, redesigned them myself so that made this not as tall, a couple other little improvements so that they will go in and out. But you still have to get in there and check and find burrs, because what will happen when you put this thing together, the scroll plate, by the way, while it's here, show you, this is the way this works. This gets turned, and when it turns, it dials it in and it screws in. So it works its way down. So if you don't watch it, any type of bump, whatever, will cause a jam up, and you have to work them out, file them out, that type of thing. Now, this was done at standard. I use a Cura software to set up my STL files and to get the G code to run off of my Ender 5. So that's how I do my printing. The one thing on this, I found out that no matter how well what quality that you set it at, right here at the end of the spiral, this is a spiral, and as it spirals out, when it comes to here, it comes down to a point. It's always got a little nick that goes in, and what I do is I take a knife real quick and I'll come in, slice off just about 1/8 of an inch, come in here at a 45, and then get that trimmed out. Then come in with a file, and it's usually pretty good. So let's see how well. The scroll plate goes on top of the house. The spring clip, which I need a clip, I got a bunch of them. You get a blue one so stands out. The clip goes on here like that, and that holds this thing together pretty well too, just with that little simple clip. There's a groove right here on the housing that it attaches to. So what happens is your scroll plate spins. Now this one runs real well. What you do the first time you do it, when you rub it like this, it gets those bumps and it starts rubbing the little nubs and bumps off, that type of thing. Now this scroll plate was nowhere near as good quality. You can see all the places I've had to sand. Over here you can see this. This end was terrible. I've been filing on that thing for ever. Still fits in there. I think you can hear it, but it doesn't run quite as smooth. It's a lot better than what it was when it first started. So there's the bottom. Press them together, rub them, get some force, and it works its way usually. Okay, here's how this works. Spin this until you find the beginning of the spiral. Want to come up, see right there it is. All right, we want that to back out just a little bit till it disappears slightly. Then you take your 3 jaws that you're going to have. On these, I've printed, like right here, this is C. Well, this is C. This is B. And this is A. Which one goes first? There is an order. C goes first. I know, I marked it wrong. Well, I didn't, but it was, make a long story short, I got C goes first. Now you put C in, hold just the scroll plate for now, twist. It's already locked in. Coming the next space is where B will go in. Come up until you, let's see if I can, there it is. There's the beginning of the spiral. So we put B in. See how the flutes are in line? They're in line with the curve so that it glides around. So concave side down, place B in, move that. We've already gone past the beginning of the spiral, so it's locked in. Come down here, now we're going to do A. Same way. It's in there. So now I'm going to hold the housing now. So these will, what you do, turn the scroll plate. You can see it starting to move in. What it's doing is basically screwing it down. What happens, that makes these move all at the same rate, and they move towards the center. What I did is I designed this one, these to go in the center. I got the other ones that are designed so that you can take this off and put this on the end. Give you a little bit more range to go out. You can grab a Yeti cup easily, big Yeti cup, 42 ouncer with these, no problem at all. Now, as you're going in and out, you're going to find you run into bumps, and it's going to tighten up or on you or something. And then, but like right here, this one was done in high seat. I had to sand this down. I actually took a sanding block onto this to get those bumps off. Just work it like that. Just spin it till the gum just start falling out. Just like that, this thing's apart. Okay. The other thing that we need to talk about is eventually the shaft is going to go. This is the shaft that you're going to find in the construction that goes into the bearings, which attaches to the main body of the. Let me grab one of these, the latest one. See, this is actually pretty sturdy. Here's how this normally would just slide out, but what it is when I get it into the construction of putting this together, you see that right here I got 2 set screws that go in here. If I take these 2 screws out, this thing just slides right off. No problem at all. The only thing these are number 4 wood screws, number 4 3/4 inch. When you buy these, do not get brass. It's steel, zinc coated. Don't get brass. Learn from my mistake. I had to cut one out because the brass is soft and it just snapped off. And the only way I could get it out was to take a Dremel tool and cut it out. It's somewhere in this box of parts. So that's the key things about the PLA plastic that's going to be printed out and coming in the kits. I will do in the kits, I'm going to work the major problems out. I'll probably pre-connect them just to make sure that they're in good shape. Now, one other thing that's going to happen here. What happened to it? Oh, there we go. I wanted to show you something that I've dreamed up, and it's the latest and greatest. Is currently on the printer. You can probably hear it going in the background. This is my super duper. Let's find the beginning of the spiral. Super duper arm. What will happen here is these are going to be threaded. I don't have it currently, but it's on the printer right at this moment, where what you can do is you can run your bolts in and it will self-tap into this plastic piece, and it is strong. It will hold up. As a matter of fact, this piece was the trial originally, and I actually used a tap to thread these. Not necessary. One thing you got to do it won't be this easy because these have already been tapped. Also, the holes are not going to go through the final product. Let's find the beginning of the spiral. I don't think I've got a third one. Oh, yes, I do. This one's got a lot of, oh, I haven't prepped this one because the supports are still in there and have to be drilled out. That won't go in. We'll talk about that in a second, about what to do when you're printing. But anyway, look how big of an item that you're going to be able to handle. I haven't checked it yet, but I think I may run into a little problem and have to limit the length of these because of the hitting the head of the laser. I don't know. I haven't gotten to that point yet, but whatever, it will basically, what's going to happen is I'm going to get to the maximum of what the laser and the rotary can do together as far as height. It's going to be maxed out with these things. I'm not providing these in the kit. I will provide them as an extra because it takes 5 hours to print 3 of these things. I'm going to make a list of every part on a document that states what you should do for the infill percentage, basic, and also how it should be set down. Like these should be set down with supports, and then also you would want a blocker so that you block, get some point with, so that you block the 3/4 of this, so it only does the support, so it's supporting this groove here. That's all you need to really support. You don't need to support the holes because that causes this type where you got these gobs out, and the only way you can get them out basically is to drill them out. Not good for what we're looking for. So if you block off the support for the holes but leave it for this base groove, has a very good final product. This one was done that way. So you can see the holes without support. Okay. That pretty much does it. I know this is a lot. I wanted you to know exactly what you're getting yourself into when you buy this kit or you buy these drawings. And I hope this presents to you that I am going to be here to support you. And I will be answering any questions that you've got. So, if you've looked at this video and you decided that, hey, not too bad, you want to buy it, please do. Happy to help you out. So, if you got any questions, let me know.